Principal ma'am's sound is not clear, ma'am. Okay, ma'am.
Okay.
Do I start? Good morning to one and all. On behalf of Bharatiya Mahavidyalaya Amravati and Indian Women Science Association Amravati branch, I, Meena Doibre, welcomes you on today's webinar, Wondrous of Chemistry. We are celebrating this year's National Science Day with this online lecture of Dr. Prakash Vadgaonkar from National Chemical Laboratory, NCL, Pune. This webinar is being jointly organized by Science Faculty of Bharatiya Mahavidyalaya and Indian Women Science Association Amravati branch. And this lecture is supported by BRNS DAE under Popular Science Lecture Series. To begin with, I request our principal ma'am, Dr. Aradhana Vaidya, for introductory remark and welcome speech. Over to you, principal ma'am.
Madam, please unmute. Vaidya, madam, please unmute.
Is it okay? Am I audible? On behalf of Bharatiya Vidyalaya Amravati, I extend a very warm and hearty welcome to one and all. My special welcome goes to Dr. P. Vargas, renowned scientist, researcher, and academician. I would also like to welcome all the delegates who have joined this webinar. On the occasion of National Science Day, I welcome all the people, all the students, all the staff, all the academicians who are interested in the world of science. Today, as we see, science is about to play a very important role in whatever is happening around us. This world of science, and especially the world of chemistry, is very interesting, amazing, and complex. And at the same time, it gives you a lot of knowledge around about whatever is happening around us. I would not like to speak on this topic as we have a renowned speaker who will be speaking on this topic. Today, Bharatiya Vidyalaya has taken this very important step in introducing all the students and the academicians and scholars, of course, to the world of wondrous world of chemistry. Bharatiya Vidyalaya is situated in Amravati. It is a multi-faculty college, and we have a wonderful staff who is devoted to improving and to uplifting and to upgrading all the students and the scholars. I would like to congratulate our staff members, especially Dr. Deepa Surkarni and Dr. Pallavi Singh, who have taken this initiative in organizing this webinar. During this pandemic, especially when we all are under fear and under the scare of something very wrong happening around us, it is indeed interesting, and I'm really happy to know that there are people who are still devoted to the subject, devoted to the studies, and are interested in helping out people, reaching out to people with such wonderful topics, such wonderful lectures. I'm sure Dr. Prakash is going to throw light on a number of interesting facts about chemistry and the world of science. And I'm not actually the right person to speak on this, but what I feel is necessary to state here is that all the faculty members who are staying now, especially as you know, and I would like to again repeat this, that Amravati is going through tremendous strain, stress, and a very difficult time because this is now being called as the Wuhan of India. We have number of COVID cases coming up, and it is really a very scary atmosphere to live in. And during this such period, we are also, along with the scare of this pandemic, along with the scare of stepping out of the house, now we are at present in the lockdown. Still, we are devoted, the staff is devoted to the study, staff is devoted to research, staff is devoted to organizing such wonderful webinars where we can interact online with academicians who are on the same platform and who can help us to understand the world around us better. I once again welcome all of you for this webinar, and I take your leave expecting that this webinar will help us all understand the wondrous world of chemistry. The tour on to this world is going to be a very wonderful one because we have a renowned person like Dr. P.T. Vargas speaking on this. So let me wish all the best for this webinar. And thank you very much for inviting me over here to speak few words. Thank you.
Thank you. Thank you, Principal Ma'am. This popular science lecture is arranged by our college in association with Indian Women Science Association Amravati branch, which is supported by BRNS DAE, and I request Dr. Deeplakshmi Kulkarni ma'am, convener IVSA Amravati branch, to introduce IVSA and branch BRNS DAE Popular Science Lecture Series and introduce today's speaker, Dr. Prakash Vadgaonkar sir. Over to you, Kulkarni ma'am.
Thank you, Manamana. As you know, we have organized today's lecture with the Science Faculty of Bharatiya Mahavidyalaya in association with Indian Women Scientists Association, Amravati branch. Let me take you through the IVSA. This Indian Women Scientists Association is a representative body for women working in natural, physical, and applied sciences, and is an all India social welfare, non-political, non-profit NGO. It was registered in 1973. IVSA was started by a group of 12 young, committed women scientists, and today IVSA has nearly 2,500 members in different parts of the country. IVSA has 10 branches with its headquarters in Vashi, Navi Mumbai. The branches are Roorkee, Hyderabad, Pune, Nagpur, Kolhapur, Delhi, Kalpakam, Baroda, Lucknow, and Amravati. Amravati branch of IVSA works with some mission and it carries out different activities throughout the year. Our mission is to take science to masses, to develop a scientific temper in society by disseminating scientific knowledge through lectures, seminars, exhibitions, workshops, etc. And to promote accomplishments in science and technology among women. For this, we conduct various activities which includes community activities, science education, science popularization, environment awareness, etc. The, these are some pictures of the activities which we have conducted in last few years, like the guest lectures, the environment awareness activities like seed ball making, plantation, slogan writing competition organized for the college students, the for skill development and a step towards eradication of plastic. We have organized workshops for students at various colleges. Paper bag making workshop were arranged by the IVSA at various colleges, and these workshops were also arranged for the women's small help groups. The IVSA also, Amravati branch also conducts various health awareness activities like lectures on nutritious food, yoga workshops for students, and for taking the poison-free vegetables and fruits from our kitchen garden itself. We have also organized a workshop on kitchen garden in association with Marathi Vignan Parishad. The IVSA Amravati branch celebrates Women's Day every year with universities and colleges. The IVSA Amravati is conducting a lecture today in a series of BRNS supported lecture. BRNS supported lecture series are being conducted by USA for past several years. These lectures are called Popular Science Lecture Series. And under this series, we invite an expert speaker to give a lecture on a topic of current interest to college students and faculty. Generally, BSc, MSc, PhD and research students as well as the faculty members attend these programs. The idea is to motivate students to take up a career in science. Today's lecture of Dr. Prakash Vargas sir is to continue this series. I take this opportunity to give a brief introduction of Dr. Prakash Vargas. He is an emeritus scientist, Polymer Science and Engineering Division, Polymer and Advanced Material Laboratory, CSIR, NCL, Pune. Vargas sir has a special interest in the research field like controlled polymerization methods, monomers and polymers from renewable resources, high performance polymers, polymers for optoelectronics, associating polymers, polymeric materials for gas separation studies, self-healing polymers, click chemistry, PDMS, elastomers for maxillofacial prosthesis, and UV curable coating. Dr. Prakash has completed his undergraduate and postgraduate education from Shivaji University, and he has done his PhD from University of Pune, where he has completed his research work in NCL itself. He has started his career in 1982 as a senior scientific assistant at the Division of Polymer Chemistry at NCL, and he rose to chief scientific position in 2011. He worked as chief scientist from 2011 to 19, and presently he is working as emeritus scientist in Polymer Science and Engineering Division, NCL. Dr. Prakash has received various awards and honors. The important ones are the Dunlop Award, the CSIR Technology Award, Professor Sukumar Mehti Polymer Award, and Scientist of the Year Award as Jeevan Gaurav Puraskar conferred by Solapur University. Dr. Prakash is a member of various committees, and he has also worked as visiting professor, visiting scientist, research associate in India as well as in foreign universities like France, USA, Australia. He is also on editorial board of various Indian and foreign publications. He has a number of patents. Of them, 23 are international and 2 are Indian. He is also visited various countries like USA, Canada, France, Italy, Belgium, Netherlands, Brazil. We are very glad to have such an eminent personality with us today. I request Dr. Prakash to start with his today's topic. Sir, please.
Good morning. Greetings from NCL Pune. And at the outset, I would like to thank Professor Deep Lakshmi Kulkarni Madam for a very generous introduction. Again, I am grateful to Bharati Mahavidyalaya of Amravati for inviting me. It's really an honor and pleasure for me to be part of this wonderful webinar. And at the outset, I would like to compliment the principal of the college, Dr. Aradhana Vaidya Madam. And I'm also grateful to Dr. Meena Doibule Madam, Deep Lakshmi Kulkarni Madam for giving me this opportunity. So what I would like to do this morning is to tell you something about, the wondrous world of chemistry. Of course, this is, not going to be a very too technical presentation, but what I would like to do in tune with the motto of this Women Scientists Association of Amravati branch, the idea here is to motivate and inspire the students, okay, to pursue careers in science in general and chemistry in particular. That's what the objective of my today's presentation is. Uh, so those who are expert, please forgive me, because I need to cater the needs of the undergraduate students, postgraduate students, researchers, and faculty members. So I will try to keep it very simple, and those of you who are interested in knowing further details or some advancements in the field of chemistry, we can have a discussion at the end of the presentation. Okay. So let me begin with the presentation and what I have shown on this slide. By the way, am I audible, and can you see my slides well?
Yes, sir.
Yes, sir.
Okay, great.
Yes, sir.
So, okay, then I will go ahead. Okay, so on this first slide, what you see is a front view of National Chemical Laboratory, which is a premier research laboratory of India. This is a constituent laboratory of Council of Scientific and Industrial Research. And in our country, there are around 38 laboratories which are spread across the country. And as far as chemical sciences is concerned, this National Chemical Laboratory located in Pune is the premier research laboratory. Okay, so this is really a modern temple of India, and I would like to congratulate the organizers for arranging this seminar. On the auspicious occasion, like we are going to celebrate Science Day on 28th of February, and there are a lot of programs being organized in various colleges, universities, research laboratories. We also have at National Chemical Laboratory a full day program where students are presenting the posters. So this is really very vibrant. A lot of activities are going on in our country, and we also recently celebrated Women's Science Day. So this is really a nice occasion that the Amravati branch of Women Science Association has organized this popular lecture. So I am going to take you through a tour of chemistry. I mean, in the field of chemical sciences, and of course, as the principal madam mentioned, this is an enchanting journey. I tell you what, In fact, I have been practicing chemistry. I mean, polymer science in particular for the past 40 years, and there was not even a single day when I felt dull. Every day is so challenging, so exciting, and I feel very enthusiastic, when we talk about the subject of chemistry. Okay, so I hope I will be able to inspire the young minds, the young brains, who are the futures of our country. They are the pillars. Okay, so that's the objective of my presentation. So before I really get into the field of chemistry, let me first tell you the importance of science, technology, and innovation. Okay. Now, all of us want to have comfortable life, okay, and that's why all of us work hard to get some good position, earn money, and be happy about what we do, okay. And if you look back, the lifestyle of a caveman, okay, and I'm sure this has been taught in your undergraduate classes. The life was not so comfortable, in the earlier days when the science and technology was not developed so much, And what I'm talking about here is just, if you look back, 300 years before, the lifestyle of the human beings on this earth was not so comfortable. And, in the modern world, that is today's era, we are all enjoying very comfortable lifestyles. And, we should be actually thankful and grateful to the scientific developments. And, because this has led to so many technological advancements, and that has made our life comfortable. So to say, science and technology is very, very important part of our lives, and it's important for any nation's development and modernity. Just to emphasize this point further, we call United States as the developed country, and there are of course many countries in the Europe, Japan. They are all developed countries, and they are developed because the science in those countries has developed, and their technologies have been developed. And as far as India is concerned, our motherland, we are still a developing country. We are not yet there compared to United States, and that's why we need people or the students who will opt for science, because unless we have that might of the technology, the other countries will not honor us or will not respect us. And that's why our beloved, Dr. Abdul Kalam used to say that we will achieve freedom when we are technologically not dependent on other countries. So that's why for progress of any country, we need to have technology, and we need to have developed science. Of course, science is universal. Okay, but then there are certain strategic sectors, or there are some niche technologies which we cannot borrow from other countries. We'll have to pay the heavy price for getting those technologies. And this, I think, we have witnessed during the time of COVID. you know when this COVID came to India, I mean, it was unfortunate, of course, but then we were short of PPEs, which is of course a common name now. We didn't have the swabs, we didn't have the medicines for those treatments. Okay, and then we cannot depend on other countries for these kind of supplies of the swabs, which are used for taking samples, or PPEs, which are used to protect the frontline workers. So I don't think, I need to emphasize this further point further, that we need to have our own technologies. Okay, so that's why, a nation without science and technology will remain underdeveloped. Okay, and if you want to be there, in that league of countries like America or Europe, we need to develop our science, and we need to have our own technologies. And why science is important? Because today's science is the technology of tomorrow. Okay, that's why we need to develop the science, and we need to develop the technology. And that's why we need to inculcate this interest in the young minds, or the future I mean, the citizens of our country, who will opt for science, and then scientific temperament, and careers in science. Okay, now if you look at this history of humankind, okay, we have gone through several ages. And the first ever technology which was developed by humans on this planet is the agriculture. In fact, many times we don't consider agriculture as a technology. No, but let me tell you that there is a science involved in agriculture, and there is a technology involved. Okay, and then if you look at this, developments in the history of mankind, we have gone through several stages. And of course, I can go on for hours together talking about these technological developments. But what is more important to know is the materials are very important in the progress of mankind, or with the development of technologies. Then we talk about stone age, earlier days, because these are the kind of materials which were available to the people. They just made some houses or some weapons from stone. And then came the bronze age, then iron age. And what we are talking about today, in the last 100 years or so, we're talking about the wonderful material, that is a plastic. Of course, there's a two sides of this coin, which I will of course develop on this topic a little bit. But we need materials, be they natural materials, or semi-synthetic materials, or synthetic materials. Meaning, synthetic means man-made materials. Okay, so we have been all along, I mean, the humankind has developed several materials, and using these materials they have developed technologies. Okay, and all this scientific revolution, or the technological revolution, started with the invention of will. Okay, and then you know that if there is no will, the modern world would not exist. That's the importance of the will. And then all these materials like glass. And we talk about technologies like the writing technology, the printing, and the material like graphene was invented in 1985. Okay, so you see that all along the history of humankind, there have been materials. And what we are talking about in today's time, we are talking about advanced materials or smart materials. Okay, so materials are very important for the progression of mankind. This is the point I just wanted to emphasize here. Now, in the earlier days, whatever technologies were developed, be it steam engine or telephone or television, all those, those, I mean, machineries needed instructions. And what we are talking about in today's time, are the smart machines. Okay, because machines don't need introduction. What I'm referring is to, like, technologies like robotics, etc. And also the technology is changing so fast. It's really mind boggling. And This is the point which I wanted, the young students to appreciate and understand. Okay. Now you see, what I've shown here in the top part of this slide. This first phone call, it was actually invented in 1876, and it took almost like 150 years for us to get this first website, which happened in 1991. Okay, but the first iPhone, which came into existence in 2007. So you can see these are the some of the groundbreaking discoveries or invention, and the time for these kind of advancement is reducing, from 115 years to 16 years. Okay, and the same about this, the printing press. The first printing press, which came into existence in Mainz in Germany. It happened in 1448. Okay, and then we had to wait for almost 500 years before we got the computer printer in 1953. And now what we are talking about in today's era is 3D printing. Okay, and it's like a Xerox machine. We can actually print the body parts even. So this is the kind of technological developments which are happening around us. Okay, and that's why the students should be prepared to appreciate, understand, and contribute to these kind of technological developments. And this will possible only if we have a strong base in science. That's the point I wanted to emphasize here. And that's why these are called as disruptive technologies. Okay, these are the breakthrough technologies. And it's very difficult to imagine like what kind of the technologies will be come into play in the times to come. Okay, so we all should be prepared for that. So this is the some general background which I wanted to share with the students here. That we definitely need technologies for the improving the quality of life. Okay, and we in order to develop the technology, we need a strong base in the science. So science is very, very important. Okay, now let me switch gears and talk to you about the discipline of science, the chemical sciences. I don't think I need to define to the students here what is the definition of chemistry, but what is important is that we the chemists deal with these elements which are in the periodic table. And I'm sure periodic table is actually present on the walls of all undergraduate laboratories. It's there on the textbook, but there are 118 elements, okay, from which the entire universe is made. So this is the importance of chemicals or elements. There is no material in this universe, okay, on this planet Earth, or even in the sphere, anywhere in the this universe, which is not made up of elements. Everything around us is made up of elements. And that's what the importance of chemistry is. There is hardly anything, I mean, there is nothing in this universe which is not made up of chemicals, and from the chemicals we get those materials. That's why the science of elements is very, very important. And that's what chemistry deals with, these science of these 118 elements. Not that all of them are found in the product. I mean, there are some inert elements or some rare earth elements. I will not get into all those details, but the point here to remember or to appreciate is that this entire universe is made up of materials which are made from these 118 elements. Okay, now talking about chemistry as a discipline, these three words are very important. Chemistry is central, chemistry is useful, and is a creative science. And this is what was said by Professor Ronald Breslow. Okay, and to me, in fact, these three terms are very, very important, and these are actually very appealing terminologies. Why the chemistry is central, I will going to explain to you in the next slide. And it's a useful science. No, of course they say that all the disciplines are important. Of course I don't have any bias. Physics is also important, geography is geology is important, even biological sciences are important. But if we have to choose between all of these disciplines, the chemistry is much more useful compared to other disciplines of science. And it's creative. That's something very, very challenging, is something which is very, very important, because it is intellectually stimulating. Because one can create the substances which never existed in the nature. Like we have seen that in the earlier days, people discovered many new materials which did not exist in the nature. Okay, And that's how all these technological advancements are possible, because of the developments of those newer materials. Okay, so chemist can create new materials which never existed in the nature, and those are called as synthetic or man-made materials. Okay, and of course chemistry is highly useful. I'm going to show you in the next slide how useful it is. Of course the physics can be romantic. Like we talk about space science, astrology, all that, but it does, I mean, there are implications, there are applications of all of these, but amongst all of these branches, I think chemistry is much more important. This is what the point I wanted to emphasize. Okay, next. Now, how chemistry is central. Okay, now what I've shown, of course, these divisions or partitions were made just for the sake of convenience. Because if you divide those subjects into different branches, it becomes easy for the students to comprehend and understand. Okay, that's why in colleges we teach science as biology, biochemistry, pharmacy, physics, earth sciences, oceanography, etc. Okay, but you can see from this diagram here, chemistry has connect with all of these branches of science or disciplines of science. Chemistry has connect with biology, chemistry has connect with biochemistry, pharmacy, physics, earth sciences, oceanography. And for the students to appreciate and understand, I just would like to tell you that when we talk about material science, which is a branch of physics, what we are talking about is nothing but the materials which are made up of chemicals. So basically, material science is, so to say, it's actually chemistry. Or when we talk about biological reactions, biochemistry, it's nothing but again, chemistry concepts. Okay. Now we talk about pharmaceuticals, drugs, which we need to take when we are sick or ill. They are all nothing but chemicals. Okay. Then when we talk about earth sciences, like the subject which deals with oil or rocks, etc., they're all again chemicals. Oceanography. So this is what the importance of chemistry. That's why this is called as a central science. Okay. Now you can see that physics is not much connected with say biology or biochemistry. Of course, I mean, I'm not saying that there is some connection, but chemistry is connected with all of these branches. And in fact, some of you may be wondering, how is chemistry connected with psychology? Okay, psychology is to deal with these thought processes. Okay, how the mind works. Okay, and then you can see that whenever we like feel sad or when we feel happy, but there are chemical reactions which happen in our body. Okay, these are all emotions. They are all related to chemicals. So even psychology is considered as a branch of arts that is also connected with chemistry. Okay, and chemistry is also connected with the art. Okay, you can see that the colors, what we talk about, the various different designs, etc. So chemistry, that's why is a central science, and it will not be an exaggeration, if I say that chemistry is our life and chemistry is our future. Okay, and again, just to give you analogy for the students, to understand the importance of chemistry. What is the importance of our heart in our body? If the heart stops beating, the life does not exist. Okay, so that's the importance of chemistry. And now this was about the central position of chemistry. Then how chemistry is important, because like I said, it's a useful science, it's a creative science, it's a central science. And here, again, I can give go on and give a 1 hour lecture on the importance of chemistry. But to me, the picture speaks better than 1,000 words. So what I have shown here is some prominent, pictures which tell you how chemistry is important. Many times we don't appreciate, or we just take it for granted and don't think about these are the chemicals. Just to tell you about something, the basic needs like food, shelter, okay, the air, what we breathe, they're all chemicals. Okay? And what these developments in chemistry have, how they have impacted the human life, just to give you example of agriculture. Okay, now in the earlier days, when the caveman, the only profession or the only objective for them was to go to jungle or forest and earn the food. Okay, that's what everybody was doing in the earlier days. But in today's time, many of us don't work in the farm, but still we get food to eat, because there are only certain number of farmers who practice, the modern technologies, and which are again based on, the products of chemistry. Just to give you an example, in the United States, only 3% of the population works on the farm, and they produce food grains which are enough for, not only enough for their own countrymen, but they also export around the world. And this is possible because of the newer pesticides, their agricultural practices. This is another example. And then another, the point which I think is very appealing is the life expectancy has gone up. In the earlier days, in fact, just think of your grandparents or great grandparents. The average life expectancy in those days was hardly 40 years or so. Okay. Today in India, actually, the life expectancy of a man is around 67 years, and good news for women is, it's around 73 years. Okay, and this is possible because of the newer medicines, you know, newer drugs, which are again the products of chemistry or the chemical science. Okay, so in fact, everybody wants to live longer, and that's possible. And everybody wants to live a comfortable life, and that's made possible because of this, chemicals. And then we have all these textiles, warm clothes, all those things, then houses which are air conditioned, and then transistors, petroleum product, transportation. As you know that, in earlier days, it used to take months together, if somebody wants to travel from India to say New York, Mumbai to New York, but in today's time, you can just make it in 8 hours. Okay? All this is possible because, we have all those aircrafts, the petroleum products, the diesel products, all those things. Okay, so you see that, chemistry is everywhere. And the most appealing, photograph I just would like to show you here, this woman who's probably never went to the school, but how happy she is. And because she's been, able to talk to her son or daughter, using the mobile phone. And mobile phone is the darling of our younger generation. And this mobile phone, just friends, I just want to tell you that, contains around 80 chemicals. The products which are made through, chemistry. There are around 80 chemicals which are present in your mobile phone. So all these developments are possible because of the, developments in chemistry. So chemistry is very important. Of course, this has just not happened overnight. There are, so many remarkable people, the talented people, who have made contributions. And here is the actually appeal to all of you that, you also can, I mean, younger students especially, can make contributions, to these scientific developments. I mean, like, and advancing the knowledge, frontiers of knowledge, or developing those products. So we, should be, grateful, or, to all those, remarkable people or talented people who made all this possible. Okay, so I just would like to quote here, what Isaac Newton said, and I don't think I need to introduce to you what are his contributions, but he was so humble in telling, if I have seen further, it is by standing on the shoulders of giants. Okay, though he made so many seminal contributions, but he gave the credit to his preceders, who made all those, groundbreaking work. And that's why, in the chemistry also, so many generations of scientists, who have made tremendous contributions, and that's why we're able to enjoy the, fruits of this chemistry. And I've just shown some few selected pictures here. There's no bias again, but, I think students can easily relate to these names, because this is what they have been studying in their textbooks, like Emil Fisher, Robert Robinson, Robert Woodward, Ingold, these are some of the names, uh, we bow our head with respect, when I see these photographs, because they made so many tremendous contribution for the growth of science and chemistry in particular. Now, as far as, chemical production is concerned, the synthetic chemicals, like I said, there are 118 elements in the periodic table. I mean, these exist in the nature. Okay, and of course, there are so many chemicals which are also present in the nature, because Mother Nature is a, great scientist, and in fact, it's the great inspiration to Mother Nature. The kind of science which happens in the Mother Nature. But then humans are also, curious, and that's what, the main quality of a scientist. Why, when, how, and this is what it occurred to, this German scientist Wohler, and he is credited for the synthesis of urea. Again, I think the students are aware of it, but I just want to bring up this point again because he is the one who made the first synthetic chemical in the laboratory. This is the synthesis of urea. Otherwise, urea is produced in the kidneys of animal and man. Okay, so people always believe that you need a kidney of a man or an animal to produce urea. But that myth was broken by this scientist Euler, who published this, his paper in 1828. And in fact, this was a landmark discovery. It's called as the birth of organic chemistry as a discipline. Okay. He made this product for the first time in the laboratory, which is considered as the birth of organic chemistry as a discipline. And you can see that this happened in Europe. That's why I say, Europe, America, these are all, developed countries because the science, the initial, developments happened in that part of the world. Of course, now, of course, India also, there are a lot of things which are happening. But this is what, earlier what people thought, only you need a kidney of the man or animal to produce urea. He made it in the laboratory, demonstrated. And that's actually called as the, chemical revolution or early beginning of organic chemistry as the branch. Okay, next. Now the question is, of course, I already mentioned that Mother Nature is a great scientist. There are so many chemicals, so many products which are produced in the nature. Of course, I must again make it clear to you that the food what we eat, it's still produced in the nature. Though so much of developments have happened, uh, in the field of science and technology, food we don't produce on commercial scale in the laboratory. That's why Mother Nature is considered as an ultimatum or is a great scientist. You can draw a lot of inspiration from Mother Nature. Of course, there have been some reports wherein people have been able to make some proteins from air, using nitrogen, oxygen. Those are the kind of reactants. Or meat also has been produced in the laboratory, but it still doesn't have the same texture or the same taste what actually is produced in the nature. Okay, but that doesn't mean that but of course there are many other products which did not exist in the nature have been made by man, and that has enabled the developments in those technologies. Now the question, somebody may ask, if there are so many materials which are available in the nature, what is the need to go for semi-synthetic or synthetic or man-made materials? Okay, and the question is answered here, partly. As you know, like throughout the history, man has needed materials, to make some components or some part. I'm not talking about even machine parts, but this kind of shirt buttons, or ornaments, so earlier people used to kill elephants, to get the ivory. Okay, and then make those kind of products, because ivory is quite tough. But then the question is, in today's world, the kind of population what we have in today's world, can we really depend on animals to get these kind of products? And moreover, animals also have a right to exist. Okay, and this is what I think this pandemic has taught us. Okay, man not conquering the nature, but man with the nature. I think this is the kind of concept, So we definitely need this environment. We definitely need animals, the bees, everything, all those which exist in the creatures are all needed, to have the eco balance. Okay, so that's why we cannot depend on the animals to get this kind of products. So that's why they say need is the mother of invention. Okay, so whenever we need something, we try to invent or innovate. Okay, and then this is what exactly this Alexander Parks did. He developed a product which has got characteristics or properties equivalent to ivory by mixing camphor with sulfonic acid with cellulose. And as you know, cellulose is a natural product. Then again, talking about this electrification industry, where we need insulators. Okay, and now earlier days people used to kill these bugs, the shellac, from which you get these insulating materials. But again, imagine for today's modern world, because the world is actually driven by energy, or majorly electricity. Now, in order to get those kind of insulators, we cannot keep on killing these bugs. Okay, and that's why this Leo Baekeland, in 1909, he made an insulating material, okay, based on the reaction product of phenol and formaldehyde. Okay, these are the two simple chemicals which are available in any undergraduate laboratory. Hello? 63 something. Hello, madam, there is some disturbance. Madam? Hello?
Please continue,
okay.
sir.
Okay, there was some disturbance, okay. I hope you muted him. Okay, fine. Thank you. So, this Alexander, Leo Beckeland, he made these two, product based on reaction of phenol and formaldehyde. And again, for the student community, especially, I just want to tell you that, why the basic understanding of science is important. And as you know, this phenol formaldehyde contains carbon-carbon bond. And as you know, metals are good conductors of electricity, while these organic materials, they are insulators or bad conductors of electricity. So based on this principle or based on this understanding, fundamental understanding of the material properties, he prepared a polymer which is film forming, which has got some good mechanical properties. So this is how the science and technology develops. So the point I just want to tell you here is we just cannot adapt the lifestyle where we cannot indefinitely depend on the products which are gifted by nature. We definitely need semi-synthetic or synthetic materials, and this is why that's why we need chemistry. We need those kind of developments in chemistry. Now, talking about chemistry, of course, where all these chemicals come from, like I said, we have to depend on those 118 elements to get the materials. But when we're talking about the products which we use in our day-to-day life, like fuels, solvents, plastics, fibers, oils, they are basically the products of petrochemical industry. Okay, so today's chemical industry is basically a petrochemical industry. Again, I will not get into all those details, but there are 70,000 plus chemicals which are manufactured, organic chemicals which are manufactured in chemical industry. But if you go back, there are 7 basic building blocks, and all of them actually come from these petroleum resources. That's why in fact carbon is called as the king of the elements. Okay, the many of the organic chemicals are you'll see that their carbon is found in all those organic chemicals. But these are the 7 basic chemicals like syngas, ethylene, propylene, butane, butylene, butadiene, and BTS, which is a mixture of benzene, toluene, and xylene, from which all of those 70,000 chemicals can be made. And how this is possible, through the knowledge of or the power of organic transformations. And that's why it's important to develop the understanding of these chemical transformations, which are taught in undergraduate colleges, like reactions of phenolic OH group or alcohol or halides, etc. Because unless you have strong and sound knowledge of those kind of transformations, you cannot develop newer products. And that's why the training which is the students get in the undergraduate education is very, very important, because with that power of knowledge, or the power of these chemical transformations, you can produce new materials which never existed before, like what Kohler did. He understood these principles of chemical reactions and reacted two simple chemicals and made urea for the first time in the laboratory. Now, this is something I just want to emphasize that point again. Chemistry is a creative science. Okay. Now we see that there are so many chemicals which are available in the nature, but chemists have prepared in the laboratory. So far, of course, then there is a way of classifying, counting this number of chemicals which are produced by scientists. And chemical, and the 88 million compounds have been synthesized by chemists. Isn't this is something very appealing for someone who wants to be creative? Okay, and every day, as I talk, in but I'm sure in NCL also a new chemical is prepared by some PhD students. Okay, so every day 15,000 new compounds which never existed before, are made in the laboratory. Okay, and now this number has outpassed, the number of chemicals which are produced in the nature. The number is much bigger than the nature. Okay, so man has created a new chemical world. Okay, a parallel world. This is something, the creative power of chemistry. But of course, not all of these are, of course, like these some of these are intellectually challenging. Just people just make some of these chemicals. They may not have any real life applications. But what the world uses is 70,000 plus chemicals, which are produced in various chemical companies. And these are the chemicals which are used to solve real life problems and raise the standard of living in many parts of the world. So that's the important thing. Okay. Of course, so many developments have taken place. So many scientists have made so many contributions. But if you ask me, what are those top 5 inventions that has enabled the modern world? So the world before these chemicals came into existence was a very different place, and today's world is a very different place. Okay, and you can see for yourselves. Imagine if there was no penicillin. Okay, if there was no ammonia, ammonia is the basis of the fertilizer industry. Okay, urea, and urea is the basis of all this agricultural productivity. Okay, the polyethylene, though people wrongly associate, but of course this is a topic of debate. But even the invention of plastic, the polyethylene, which is a household name, from a very simple chemical, the most simple chemical or inexpensive chemical, organic chemical is ethylene. Okay, so polyethylene is produced from that. The contraceptive pills, which is used for population control, and in particular, all these modern gadgets, the television, the clarity of the pictures, what you see in the television, this is possible because of this liquid crystal displays. Your mobile, the kind of clarity what you get, and all this is possible because of these liquid crystals, which are again organic chemicals. So these are the 5 landmark discoveries. Penicillin, ammonia synthesis, polyethylene, contraceptive pills. Of course, one can keep on adding to this, but these inventions change the world. The world was a very different place before these chemicals were made. Okay. Of course, like I said, the first synthetic chemical came into existence, the urea, just not long ago, but just only 100, around 300 years. Okay. And all this petrochemical industry, in fact, it started, in 1925 only. So it has got a history of hardly 100 years. But see the mind-boggling developments, which have taken place, and of course the chemical industry actually can be, we can see that initially there were fuels, which were made from petrochemical industry. Then came polymers, drugs, and so many instruments. Like today, in fact, we can see the atoms. With the kind of powerful instrumentation which is available or which is at our disposal, you can see even atoms. Okay, so that's the kind of progress which has happened in the field of chemistry, and it's really very enchanting or very exciting journey. Now, talking about Nobel Prizes, and then on 28th we are going to celebrate Raman's discovery, okay, or invention, and he's the only Indian scientist who has been awarded Nobel Prize for the work done in India. Okay, that's why I say we still don't have that. Those we need more of Ramans. Okay, and here what I have given just to inspire the students. And the Nobel Prize is given for some very groundbreaking work or seminal work. But even the United States, they have also had to wait till 1965 to get the Nobel Prize in the field of organic chemistry. Because earlier developments, like I said, it just all the scientific developments started in Europe. Okay, so you see all these names, earlier names, they're all European scientists. Like Bayer, Fisher, Kuhn, Robert Robinson, Todd, Nata, who made polyethylene for the first time, in 1963. So you can see that, the organic chemistry Nobel Prize first went to United States in 1965. Okay, and then you can see there are so many, Nobel Prize winners from United States. Okay. Now, this is the just want to show that how organic chemistry has developed. Okay. Now, what we are talking about urea, it's a simple formula, NH2CONH2. It's a simple chemical. And what the students learn in the textbook, of course, you need to first gather or acquire the knowledge of simple fundamentals. But organic chemists have been able to make these molecules. And what you are seeing on this slide, particular slide, is a single molecule. Okay, it's a single molecule. It is the largest and most complex secondary metabolite which has been ever isolated. And what does it contain? 32 rings, 98 stereo centers, and 1 geometrical site. Okay. And these are the kind of molecules which chemists have been able to synthesize in the laboratory. Now imagine if you were to synthesize such a molecule, how many reaction steps will be involved, what kind of isolation procedures one has to learn and adapt, and what kind of characterization tools you need to assign the structure to this kind of molecule. So this is the just the complexity of science, which probably younger generation will have to deal with, because all the low hanging fruits have been plucked. So all these today's problems are complex, and you need an interdisciplinary approach. Okay, so you need to have the knowledge of physics, chemistry, instrumentation, all those kind of branches. So that's why I just what I showed you earlier. The science was actually taught as discipline, physics, chemistry. But in today's time, what you need to do is to also have understanding of other branches of science. The students should be open. Even they also should be taught, when we teach them chemistry, we also teach them biology, we also teach them physics, because then only they can work on these kind of complex problems. Okay, that's the message I just wanted to again convey to the younger students here, because tomorrow's problem cannot be solved with yesterday's skills. Okay, so we need definitely new science, we definitely need new technology, okay, to deal with these complex problems. This I think I will just skip, the kind of science. Sorry, just want to convey the message. The number of research publications. Because when you do something new, the researchers they publish research papers, and you can see the exponential growth in terms of the publications in the field of research in the area of polymers. You can see up to 1980. There are like in 1955 there used to be hardly 155 publications per year. But this is still, the number is old. 2017, about 140 publications per week. You know, so you can see the exponential growth in terms of the science. Okay. Again, if you ask me what are those great successes, again I will just give this because and now earlier, science was more of a intuition. Like imagine how Kekule solved the structure of benzene. Okay, he didn't have all those kind of modern tools. Okay, it was more of a imagination, of course, based on sound fundamentals. Okay, and today's science has become more of a tool-driven science. Okay, because we have at our disposal all those high-end instruments or machines like nuclear magnetic resonance spectrometer or infrared spectrometer or X-ray diffraction, computers. Okay, and with this, the science, that's why it's called more of a tool-driven science. Earlier, it was more of a imagination, more of a creativity. Now again, somebody may say that if so much developments have taken place, so many complex molecules have been prepared, okay, so many new materials have been produced. But does that mean that chemical science is a matured science? In fact, the answer is again, chemistry is still in its infancy. Let me put it that way. So there is a lot more to do, lot more to uncover, lot more to understand. Okay. Now many students, many times students write in the answer sheet or in their notes simple chemical reactions without understanding much. Because none of these chemical reactions are so simple, or in fact we still even don't understand. In how can you make ammonia? Say for example, as you know, ammonia production, which is the very basis of fertilizer industry, it needs high temperature, pressure, and some catalyst. And as you know, in air there is a nitrogen and hydrogen. So how can you make them react under ambient conditions, and make ammonia? So many reactions we still don't understand. Okay, we still don't understand the properties of molecules. Okay, or we cannot engineer the functions. Okay, you cannot design the drugs. As you know, these are general purpose drugs. Now what we are talking about is personalized medicines or personalized drugs. Because sometimes, many times, we blame doctors. Because some of the patients get cured and some don't get cured. And there is a complex systems involved in all of that. I will not get into that detail. But what we are talking about today is personalized drugs. Or can we make materials by design? And in fact, the very origin of life, okay, and it just started with the chemical reaction again. As you know, the origin of life also started with a chemical reaction. Okay, now we still cannot rationalize the origin of life. So these are so many pending problems, unsolved problems, and this is what something which is very exciting. Okay, you can uncover something which is new, or you can add to the existing knowledge base. Okay. So So this was about more of fundamental problems. Now talking about something which is related to our life and death. And I think this COVID-19 has taught us this lesson. Okay, and of course, health is indeed the wealth. Whatever it may be, but like I said, we all want to have comfortable lives. We also want to have pain-free life. Okay, I think that's something very very important. Though the life expectancy has gone up, but there are so many problems associated, to live longer. In fact, the human bodies are made to live for 150 years. Okay, and like I said, now the life expectancy has gone to up to 70, around 70 in India. Okay, and here I have just listed some of the diseases. I'm sure all of you heard of this, like HIV/AIDS. And as you can see, there is no vaccine, there is no prevention, there is only treatment which is available. We still don't have a cure for HIV or AIDS. Only we have been able to control the childhood diseases. Okay, I'm sure all of you know that, but you talk about these other, diseases, and of course, COVID-19, we still don't have vaccine, or we don't. I mean, it's there, but it's still not proven. Okay, and Madam mentioned that Amravati, I think has become Wuhan of India. So you can see there is a lot of scope to develop those kind of vaccines or those kind of treatments or the cure for these diseases. Okay, diabetes, cardiovascular diseases. Okay, so all of these are under development. You can see this, cross indicates these are all under development. So the point I want to tell you, here there are so many, pending problems which are in fact directly concerned with our life. Okay. सर जी मैं मीटिंग में नंतर बोलतो sorry. So this is just one example. We need those newer drugs, newer pharmaceuticals to control or to cure these kind of diseases. So what we have been able to find cure to is only malaria and childhood diseases. Okay, that's our achievement over all these 300 years. But there are so many other pending issues or problems are there. So I just thought I will, I shared with students like, chemistry is very important. It's a central science. It's useful and it's creative. But still, we need to develop further chemistry because there are so many pending issues are there. Okay. Now, but when you talk to a common man in the street, what he thinks of chemistry? Okay. And here I just want to give one simple example, like chemistry is invisible to the public many times because there are the products of chemistry, but people don't understand which are chemicals. Oh, hello, madam. Sorry, there is some disturbance again.
I have muted him.
Black. Okay, can I go ahead, madam? Can I go ahead?
Yes.
Okay.
Yes, sir. Yes, sir.
Now, if somebody is sick or unwell, he or she goes to a doctor, and then doctor gives prescribes some medicine, and then we thank doctor for curing. But in reality, it is of course the doctor has some experience, some knowledge, But then what actually cures, the individual is those medicines, and those medicines are nothing but chemicals. Okay, and that's why I say this chemistry is invisible to the public because we don't associate everyday items are often not classified as chemicals. In fact, all these items, the comforts what we use, they're all chemicals. Even the PP kits, which has come as a saver, for the frontline workers or for doctors, but we don't consider them as the products of chemistry. And so, what is chemistry generally associated by common man is with pollution and global warming. Of course, there is no denying that chemistry has created certain issues like pollution. The manufacturing of chemicals does create pollution, and it's also the root cause of the global warming. And as you know, those gases, as you know, carbon dioxide, these are actually, greenhouse gases. So they are all, of course, definitely chemicals. But then, there is nothing in this life which is risk free. One has to definitely take risk. There is nothing, which is completely ideal. I mean, in the sense, okay, there will be always some pros and some cons associated with any of those, scientific or technological developments. Okay, the question, which we need to ask, whether we need this kind of development or we want to go back to the caveman type of lifestyle. So if you want to live in the modern world, I think there is no other way but to go for these technological developments or advancements, and that's where I think the science becomes important. So one has to always, balance the good and bad. Okay, in life, in general, but more so when we talk about the perceptions of chemistry. So this is just important message I wanted to give, because already I think it was mentioned that there was a program on banning plastics, I think, but these are probably not a good sign when as a scientist or as a students of science, we should actually weigh the advantages and disadvantages, and cannot be I don't want to be critical here, but this is the kind of message I think we should convey to the students. In fact, it's very difficult to imagine modern world without the plastic. Okay, and let me tell you that our honorable Prime Minister had made a slogan. He wanted to make India plastic free. But imagine if we didn't have the plastics, how would have fought this war against Corona? Okay, in fact, plastics came to our rescue. But as you know, there's no cure. What we can do is maximum we can prevent the spread of coronavirus, and that's possible only with these plastic materials like PPEs, hand gloves, you know, all those. So that's why I say, we should teach students, systems approach, rather than be giving a biased opinion, and this is, I think, the responsibility and duty of all the teachers or researchers or scientists to, convey the right message to the masses and also to the students. And this is what I have shown in the next picture. If you decide to ban plastics, if you say we want to have a plastic-free world, okay, this is what will be. Today we are enjoying this kind of lifestyle. Comfortable clothes, vehicles, etc. But then, if we decide to ban the use of plastics, we'll have to probably go back to the human type of lifestyle. Okay, I'm not saying that we should. Plastics definitely have caused some concerns, have definitely caused some concerns. Not only plastics, but most of the chemicals. There's nothing like I mean safe chemical. In fact, this is the wrong notion. In fact, all of these chemicals have certain drawbacks. Okay, but then there is also an advantage in using those chemicals. So this is picture I would like to just explain. If you are a blindfolded person, okay, or if you put a handkerchief on your eyes and you are asked to describe the elephant, the one who touches the back of the elephant will say it's like a wall. The one who touches the tail will say it's like a rod. Okay, but everybody in his right, in his own right, is correct. Okay, but the picture is something different. And this is what, when we want to explain something to the students, we should have a 360-degree view. Okay, and not like what is your perception. Okay, this is what I wanted to. Answers must be subjective. Okay, of course, so chemistry is definitely not bad. I mean, you don't have to take my word for it. Of course, there are certain concerns which we are going to discuss, a little bit later. But we just cannot have a modern lifestyle without chemistry. Okay. Of course, like I said, a lot of developments have taken place in the field of science and technology. But does that mean that all the problems are over? And simple answer is no. Okay. Though the life expectancy has gone up, the life has become more comfortable. But they say that when you find a solution to a problem, it comes with a new set of problems. Okay, so this has actually a loaded meaning. When you find a solution to a problem, it comes with a new set of problems. And this is a list of 10 challenges which humanity is going to face in the next 50 years. This is a list made by one Nobel laureate, Richard Smalley. And you can see we still have problem of energy, water, food, environment, poverty, disease, education, democracy, population. Okay? And that's why many times students say that what are the opportunities, job opportunities, or where they can contribute. And you can see for yourself here. Uh, these are the kind of areas where we need scientific developments, technological advancements. Okay, but like I said, in today's world, we live in an energy-driven world, and all these years, we have depended on non-renewable sources of energy, like fossil resource based. And again, this is something alarming, or I would like to share with the young students here. There will be no petrol, coal, and natural gas after 300 years. This is just a prediction, of course. Now imagine a world where we have come to depend so heavily on all of these disappear. What's going to happen to the modern world? And that's why scientists have started working on renewable energy sources. How can you harvest solar energy? That's why in order to harvest solar energy, we definitely need advanced materials, advanced polymers. Okay, then even in water purification, you need membranes, water treatment technology. The, there is a land is limited. How will we increase the agricultural productivity further? We need food, the environment balance. All of these are problems. The humanity is going to face in the next 50 years, and more importantly, in today's, I mean, like in the world population will be 8 to 10 billion by 2050. Okay, so we have hardly now 30 years. Okay, to solve these problems. Okay, like I said, the Earth's temperature is rising, global warming and all that, and of course I will tell you, the alarming situation. So definitely we need better science. We need better technology, because all of these 8 to 10 billion people have to be provided with food, warm houses and clothing. These are the minimum requirements of all of these people. Okay, and in order to do that, we definitely need to increase the supply of energy, provide water to them, and also provide food to them. So these are the kind of challenges. Now I'm sure you are aware of the Sustainable Development Goals. And you can see the 17 goals to transform our world: no poverty, zero hunger, good health, wellness, quality education, and all of this will depend on the technological advancements. So the question, I think, let us try to answer this question. So, does the world need chemistry or no? And the simple answer again is definitely the world needs chemistry, because our health is dependent on chemistry, energy, water, food, population control, information technology. We are talking about digital world. No, it will not be possible without the advancements in technology or in chemistry. Then national security, reinventing the supply chain. And this is something I just want to tell you now. All these years, what we have done, we have taken hydrocarbons from the Earth's crust and converted them into CO2. Because, like I said, the first chemical reaction which was ever done by man on this planet was the lighting of fire. Agriculture is the first technology, and the first chemical reaction is the lighting of fire. Converting wood into carbon dioxide. And as you know, this is an oxidation reaction, and we take all these precious materials, natural gas, coal, petrol, etc., and finally it ends into CO2, which is a global warming gas, as you know that. Okay. Now the question is, we have done all these years, like converting hydrocarbons into CO2, and there's so much of CO2 in the environment. Then now the $1 million question is, can we take carbon dioxide and convert back into chemicals? Like you see the kind of challenge, and we will need interdisciplinary approach, to develop the chemistry, the technologies to convert carbon dioxide back into hydrocarbons. So we don't have to depend on hydrocarbons, because they will not exist in any case, after 300 years. Okay, and understanding the living and material and information based words. So for all of this, we definitely need chemistry. And the last three sentences are very, very important here. The most important problems now facing society depend on chemistry. We have seen that again in the case of COVID. Most interesting and important problems in science depend on chemistry, and new chemistry is essential, and the field is there for essential. So this is an important message I just wanted to convey to the students. Okay. Madam, how much time do I have? I think maybe otherwise I will just stop here and we can continue on some other occasion.
Sir, you can continue for another 5 minutes.
Okay. Now, as a scientist, I think we have to be honest in sharing the information, and we should be truthful to ourselves. I think that's what science teaches us. Okay. So whatever I said, like good about chemistry, but not all is well with chemistry. Let me also tell you that. Okay. Now let's see what is the bad or the ugly part of chemistry. And this is what we see now when we are talking about chemical industry. Okay. Of course, this is the initial phase of industrialization. So you see, the chemistry is associated with pollution. The vehicles, when we run vehicles, actually we are burning petroleum. It's an oxidation reaction and CO2, CO, carbon monoxide. These are generated, and then these materials are actually, littered, like plastics, etc. So the two most important problems which the world is facing is the how do you control or minimize the waste generation, and how do we conserve the resources which are limited. Okay. I think these are the two main problems which the world is facing today: the resource utilization and the waste generation. Okay. So I think let us all remember that everything we do has an impact on the environment around us. Okay, that's very, very important. That's why environmental science is getting a lot of importance. Now, when you talk about the manufacturing of chemicals, uh, so what was the norm before 1994 was the up the chimney and down the river or into the oceans or sea or into the land. That was the norm. People did not respect so much the environment. They were interested, somehow in getting those products which change the life. But that has, that is something which has really created issues, in terms of the environment. And of course, like I said, there's no chemical which is safe. I mean, every chemical has some problems are there. Okay. And these are the kind of diseases you get, when you get exposed to certain deadly chemicals like these fluorinated dioxins. I will not get into those details. Those are the chemicals which have been banned. And this is a sort of evolution or a phase of learning. Like I said, the chemical manufacturing or industry is only 100 years old. Okay. And initially, we just went after it, using those petroleum resources or producing chemicals without probably knowing, or we didn't have those kind of tools, to detect those kind of side effects. And like any technology, it takes some time to know the drawbacks of it, okay, or the other side of it. So there are definitely certain issues which have been created by chemicals, but now I think there is a lot of learning or understanding about the properties or the effects of those on the human health. Okay, and those are the chemicals which are now being are banned. And one of those such chemicals is the polyvinyl chloride. PVC. Though it's a wonderful chemical, but it has definitely created certain problems. Okay, the PVC per se is not bad, but if you burn polyvinyl chloride, you get those kind of chemicals which are harmful. And then of course, like I was talking about this waste generation, the plastic is such a wonderful material. It has changed the world. It has shaped our world. But what we call it as a white pollution. It is associated with the plastic waste. This is what you see, all around us because of the littering habits. Okay, and in fact, they say that this Pacific Ocean, there's so much of plastic which has been dumped into Pacific Ocean that it is called as plastic ocean. Okay, now this is something again I just want to show this picture because you can easily relate yourself with this. This wonderful product of chemistry, our chemical industry or the polymer industry is this water bottle. Okay, because it's hygienic. Because all of you know that if you drink water from the water bottle, it is hygienic. Okay, but then what do we do? When the intended use of this plastic water bottle is over, we just discard it into the environment. And the magnitude of problem is such that in fact they say that the waste will bury us one of these days because the land is limited and the kind of waste we have been producing, the consumer society. Okay, so it is like take, make, and dispose. So it's called as a linear economy. Okay, and now the concept of circular economy is coming into foreplay. Like again, I will need another lecture to convey this concept to students. But I think when we teach chemistry to students, we should also make them aware. It's like these sources are limited, they are expensive, they are precious. No, we just cannot discard all these items because this is something called as a consumerism. We don't train the consumers. So linear economical model is not acceptable in the present time. So what we are going back to the circular economy model. This again, the magnitude or the complexity of the problem, in fact, they say that by 2050, the weight of plastic in the oceans will be more than the weight of fish. These are the kind of some alarming situations. Okay. And again, talking about this burning of oil, natural gas, and like we see that in the next 100 years, humans will consume more fossil fuels than what the whole world has consumed since man emerged on this planet because of the consumption, the kind of consumerism. Okay. And then again, I mentioned that, there are many elements. Of course, there are some synthetic elements, but we depend heavily on the nature for these elements. And this is a sort of a new form of periodic table. And I have shown those, elements which are under serious threat. Like we are talking about, there are certain animals, tigers, which are under threat, and we need to protect them, in order for this eco cycle. And you can see here some of the elements which are shown in red, they are actually under threat. And now today's world, we are talking about lithium battery. Like we cannot depend on petroleum, but we have to go for lithium. But then you see here, lithium is available only in limited quantities. The future is at risk. So again, so there is no rescue, but we have to preserve all these, resources, natural resources, be it petrol, oil, natural gas, or even these kind of, elements. Okay. And this is again something like, to do with consumerism, like Earth overshoot day. In fact, they say, like if you adopt the lifestyle of US citizens, we will need 7 Earths or 7 planets. And friends, again, there is only one planet in this universe, that is the Earth, on which the life exists. And if we, by our acts or by our deeds, destroy the environment of our Earth, the life will not exist. Okay. So this is the kind of magnitude of the complexity of the problem is. That's why when we do chemistry or when we enjoy the benefits of these chemicals or chemical industry, we should also be aware of our duties and our responsibilities and conserve the nature, conserve the resources. Okay, that's the kind of problem. If so, this kind of lifestyle is unsustainable. That brings me to another new concept, in chemistry, not a new concept, but which has come which has captured the great attention. Like we are talking about sustainable lifestyle, or sustainable products or sustainable chemistry. Okay? And then, of course, there are some environmental disasters. As they say that accidents will always happen. Whatever precaution you take. Okay, and I'm sure many of people from my generation will know that very big accident happened in Bhopal in 1984, and in fact that is considered as the black day in the history of chemistry. Okay, and since then there have been a lot of regulation, restrictions, laws in place on the manufacturing of chemicals. Okay, history is full of several such accidents. Okay, and then that brings us to this climate change, and nobody is spared. And I think this picture speaks for themselves. The Mahalakshmi train stranded in Mumbai is because of the heavy rains. Or in the last year in Paris, the temperature was so high. Okay, the people just could not sit in their homes. They had to come out. You can see the picture of Eiffel Tower here, and the people are actually taken off their clothes. Okay, because so rich people are also not spared. So it's, I think, very important when we practice chemistry, we also should take care of our environment. Okay, And I'm sure, the young students probably this is a role model for all the young students, Greta Thunberg. Save the earth, there is no planet B. That's what I said. And we are the last generation that can change the course of climate change, and we are the first generation that then has to live with the consequences. Okay? That's why it's very, very important. If you don't want to face these kind of painful events or the points, then I think better we worry about or respect our climate or environment. Okay. So the question is again, we that brings us to, like, we definitely need synthetic materials. And like I mentioned, earlier, we want to have a modern lifestyle. But then the question is, we have been excessively dependent on these finite natural resources, and the waste products like plastic, etc. They are non-biodegradable. They persist in the environment, and that's what causes threat to the environment. Okay. So the question, and this is something again, for the young minds of the students, can we, develop material needs of the man based on the concept of sustainability of both the resources and environment? It's very much possible, with the developments in chemistry. Again, I think I need to just probably give a coursework, maybe a semester coursework on how can we make the chemistry sustainable without all those, how can we avoid all those ill effects of chemistry and enjoy all the good things which chemistry has brought to us. So I think with this, I would like to stop here. And so there was a part two of my lecture where I wanted to talk about what are the different career opportunities. But I hope I was able to take the students through the history of chemistry. Why do we need chemistry? Why do we need science? Why do we need technology? And what are those current trends, or what are those challenges, which chemical, I mean, scientific community is facing in general, and what is the scope, or where the students can contribute. And so I hope I was able to provide that perspective and inspire the students, not only to undertake chemistry as a their career, but also the way to practice the chemistry, in not only in our day to day life, in our homes, in our societies. Okay. Because this is, I think, must, and this message has to be communicated. And I consider the students as the agents of change, and the teachers also are agents of change. And I'm sure with this kind of message should be passed on, and so that our lives will become more comfortable and less risky. So with this, I would like to stop here. And again, I am grateful to Professor Deep Lakshmi Kulkarni madam, Doibule madam, and the principal of the college, Vaidya madam. Thank you so much for your attention. And I would be happy to take any questions if you have.
Yes. Thank you very much, sir. There are many questions and queries in the chat box that we are having some from participants. Few of questions we are taking. The question is like that: can chemistry be used to correct the problems created by overuse of some chemicals? Some
Yes, sir.
problems may create by overuse of chemicals. Is it possible to solve such a problem by chemistry?
I think I answered this question in one of the slides. Like, we definitely need chemistry because there are problems which are created by chemistry, but that's because of the in any industrial revolution, the first phase is more of a learning. Okay, so with this 300 years of history in the field of chemistry, I think we know what is good, what is bad. Okay, so the chemistry which will be practiced hereafter, especially on the industrial scale, will be environmentally benign, okay, or sustainable chemistry. So definitely chemistry has the solution to these problems.
Okay, one more question is there. Um, how to reduce environmental pollution by using chemistry?
That's why, madam, I
Reduce.
like, there are clean sources of energy. I mean, most pollutant is actually the energy industry. Okay, let me tell you also the usage pattern of these chemicals. The 30% of chemicals, petrochemicals, actually goes into transportation industry. Okay, and the rest 30% goes into energy industry, and only 10% goes into manufacturing of chemicals. Okay, so we people are looking at renewable energy sources where there will be no pollution, like harvesting of solar energy. Okay, But again, to harvest solar energy, we need materials, which will be made through chemistry. Okay. The same way, like the chemical. Of course, this is again I need a separate lecture. But there are ways of practicing chemistry without causing harm to the environment. Okay.
Okay.
Like let me tell you how nature does it. Nature actually produces 10 times more volume of polymers than what we produce in chemical industry, but absolutely there is no pollution. There are recycle mechanism in place in nature. Okay. In fact, the waste of one animal becomes food for the other creature. So that's how the nature operates. So there is a recycling mechanism in place. But in chemical industry of the yesteryear, this we did not bother so much. I mean, let me tell you, there's a lot of politics also. This is not a simple problem. It's not only the problem related to science, but this is a problem related with the attitude also. Okay, of the industry. There's a politics, there is economics involved. So many. It's a complex problem. Okay.
Okay, sir.
So we can have a separate discussion, but then
Okay.
there
Fine.
are principles, guidelines. Now, in fact, there's a concept called green chemistry. There are 10 sort of commandments by which if you operate, there will be minimal pollution. Okay.
Okay, sir. The next question is why Environmental Protection Act is not strictly adopted in the world?
Again, this is more of a political, madam. I think I need a separate lecture
These are
on this.
questions from participants.
I know, I understand. But see, the rich countries, they dictate. Okay, like Trump said, I don't believe in this, right?
Okay.
Environment Protection Act and all those things.
There are some students are there and they wish to know that a career opportunity in chemistry after MSc, job opportunities.
Again, I displayed the list of areas, the top 10 challenges which humanity is going to face in the next 10 years, like energy, water, food. And, in all of these sectors, there is a scope for chemists. So, if a student is good, I mean, outstanding, there are no issue about getting a job. Okay. The world definitely needs all those talented, remarkable people. So I think there is no dearth of jobs for people who are good, who are sound in their knowledge, and who can contribute or who are problem solvers. Like there are so many problems, and we need problem solvers for that. So definitely, the young minds are needed for that. Again, coming to specifics, I have another lecture on that, which probably we can, madam, Deep Lakshmi, madam, you can arrange my talk on some other occasion, especially for the benefit of students.
Sure, sure.
So I'll be most happy to do that.
Definitely, yeah.
I didn't want to
We
combine
will
too many things.
like to have it offline.
Fine.
We'll like to have an offline lecture of you in our college.
Sure. But make the Amaravati as a safe place first. I think they
Okay,
Of
sir.
course, after that, sir.
Sure.
Thank you, sir. Thank you very much. Sir has explained in easy way that chemistry is everywhere and how the nature is great scientist. That sir have shown you us in his lecture. Okay, sir. And it's time to say our vote of thanks to everyone. Firstly, I would like to thank for coming here, our guest, Dr. Vadgaonkar, sir, giving his precious time to us. Thank you very much, sir, for coming. And we need your guidance furthermore also. Thank you, sir. Thank you very much. I would
Anytime.
like to thanks to our principal, Dr. Aradhana Vaidya ma'am, for motivating us. I would like to thanks ILSA main branch and all the ILSA members as well as our convener, Dr. Kulkarni ma'am, for organizing such a nice lecture, such a useful, informative lecture for our students and researchers. Thank you very much, ma'am. I would like to thank our technical support staff, Dr. Kalamwar sir, Dr. Kadu sir, Dr. Vargas sir, and all remaining staff. Thank you very much. And one and only, I would like to thank to our participants without whom we cannot conduct such a lecture. Beautiful participation. Everyone has given much more response and effective response and ask very nice questions. Thank you to all the participants. Thank you very much, everyone. Thank you.
Before we leave, I will like to have a screenshot of today's webinar. So I request all the staff members of Bharatiya Mahavidyalaya to please open your screen or please keep your screen on. Kadu madam.
Ma'am.
Yeah.
Okay, ma'am. We have taken many more
screenshots.
Thank
you, sir.
Thank you, sir. Thank you very much.
Thank you very much.
Thank you to one and all.
Thank you. Thank you. Thank you.
Thank you
for your patient listening.
Thank you.